what is the range? Okay, very similar to the last one. We're going to replace the x's with -4. And so, forgot squared. So -4 squared is 16, times -2 is -32, plus 20 is -12, plus 4 is -8. Then we do the next one, -2 times 2 squared minus 5 times 2 plus 4. So 2 squared is 4, times -2 is -8, minus 10 is -18, plus 4 is -14. And finally, -2 times 4 squared minus 5 times 4 plus 4, and that will turn out to be -48. So our range is a set of y values such that y equals -48, -14, and -8. Which mapping best describes the function for the domain -5, 0, 25? Okay, so domain again is our x values, so we're looking here. Those match up, these do not. So that's first off, we know that those aren't going to be the proper answer. Okay, this says -5 goes with 3, 0 goes with 3, and 25 goes with 6. So to test that out, we can replace x with -5, with 0, and with 25. Okay, that's going to be -2 plus 1, which is -1. This would be +1, and this will be 11. Okay, so I looked here. These numbers do not match at all. Check these out. 0 is going to 1, -5 is going to -1, and 25 goes with 11, just as we said. So G is the correct answer there. That would make a great test question. What are the domain and range of the function represented in the graph? Okay, so again with the graph, when it's continuous like this, we come from the left, come from the right, and we determine what are our x values. Okay, so that's -3 and 1. There are no breaks in our graph, so we would say the domain of this graph is a set of x's such that x goes from -3, includes -3, all the way to 1. And then the range, we'll find that by doing our y values. So we start from the top and we come down, and this is the first time we see anything. That's at 5. We come from the bottom. That's the first time we have any graph, and that's at 1. So the range is the set of y values such that y is between and includes 1 to 5. Okay, what are the domain and range of this graph? Okay, so we start from the left, we come over. This is the first point we see, and we're at -3. We start at the right, and we go, oh, there's an arrow. And we know that an arrow indicates that this graph is going to go on forever. Okay, in math terms, we say that would be infinity. So our domain can be represented by x such that, and right, we start with -3. It's less than or equal to x, which is less than infinity. We do not say equal to infinity because you can't get to infinity. All right? So then for our y values, we start at the bottom. Right? We come up from the bottom, and this is the first point we hit, so that's -1. And then we go up, and it's continuing on, so it's going towards infinity. So we would represent that as y. That's the range. Come on, Ms. Whitaker. Okay, y such that y goes from -1 and then approaches infinity. And again, we don't put the equal sign under these because it's never going to quite reach infinity. All right, the graph of the function y equals negative 3/4 x plus 3 is shown below on the coordinate grid. What is the range of the function when the domain is greater than or equal to negative 5? So if the domain is greater than or equal to negative 5, we would count over here to negative 5. Right? And then it would be continuing on forever this way. Okay? So if we take that up to our grid, right, that means everything this way from this line over is part of our graph. We no longer care about this part of our graph. Okay? So we look for the range, we need the y value. So we look at this point at negative 5, and we find out that that's negative 5, 7. Okay? And we look, and the graph is going on forever, but we're going down direction, so we call this negative infinity. So the range is the y values such that y extends from negative infinity, okay, because that's our lower number. We don't include it, no equal sign, but then we'll go all the way to 7, and that's where we'll stop. Okay, so just to sum some things up, you should be able to move between your different representations of a function. There will be words, equations, tables, maps, and graphs. And each one of these means the same thing. It's just a different representation, and you need to know how to move between those representations. Okay, I mentioned earlier discrete individuals, right? Continuous it's an interval. Okay, there's no breaks. There's an infinite number of points in between here. Okay, and we're only talking about the input, so we're talking about the domains, the input values, the x's. Right, the linear function y equals 15.95x represents the cost y in dollars of x tickets for a museum. Each customer can buy a maximum of 3 tickets. Find the domain of the function. So if we want the domain, we need to figure out, well, what's the input value? And I think it'd be clear here that we would input the number of tickets. Okay, so our domain is going to be our x values. So from the maximum of 3 tickets. So my question to myself is, can I buy parts of a ticket to the museum? And the answer would be no. So what can I do? Well, I cannot buy any. If I don't want to go to the museum, I buy 0 tickets. I could buy 1 ticket, 2 tickets, or 3 tickets, and then I have to stop because I'm only allowed a maximum of 3. So the domain of my function is these x values. X would be equal 0, 1, 2, and 3. Is this domain discrete or continuous? And then explain. This is a discrete graph because it's not an interval. There's nothing in between 0 and 1. So the way I like to say it is you can't buy parts of a ticket. All right, graph the function using its domain. So if we're going to graph the function, we need an x and a y coordinate. Since we're talking about tickets and money, that's all going to be positive, so I'm just going to do a first quadrant graph where all the numbers are positive. And my domain was 0, 1, 2, and 3. And I know that each ticket is $15.95. So the first time I buy a ticket, that's going to be 0. Then I'm going to go up $15.95. And I'm just going to kind of estimate here. I know I'm going to increase the same amount, so it's going to look like that. Right, so that would be $15.95 there, and then $31.80, and then this would be $47.85. Okay, y'all check my math on that one. All right, so my range then is the set of y's, so that y equals 0, then $15.95, then 3180, and then 4785. The linear function m equals 50 minus 9d represents the amount m in dollars of money you have after buying d DVDs. Find the domain of the function. All right, so looking at my equation, d is going to be my input. So d is the number of DVDs. So there's no restraints here on the number of DVDs I can buy that I'm given. But this equation starts with 50 and then we subtract. So that seems to indicate that if I bought 0 DVDs, I would have 50 M. 50, oh, that was the dollars, right? I would have $50 if I bought 0 DVDs. So if I bought 1 DVD, I would have 50 minus 9, which would be 41. And then if I bought 2 DVDs, it'd be 50 minus 18, which is 32. And then 3 DVDs would be 50 minus 27, which would be 23. Yeah. And then 4 DVDs would be 50 minus 36, which would be 14. And then 5 DVDs would be 45. 50 minus 45 is 5. And then if I went to 6 DVDs, that would be 9 times 5 is 64. I'd end up with -4. And I'm not allowed to have negative money, so I'm going to have to stop there at 5. Now, that was some work to work out. I could have probably more easily said how many DVDs will take me to 0 money. Okay, so if it's 0 money equals 50 minus 9D, right? Because then that would be 50, add the 9D to both sides. So 9D equals 50, divide by 9, and we get 9 goes into 50, 5, and repeats forever, 5. Right, so that's why we have to stop there at the 5. So a couple different ways we could have figured that out. So my domain, since I can't buy parts of DVDs, is going to be discrete. So the domain is going to be the values of not x this time, d, such that d equals 0, 1, 2, 3, 4, and 5. And it is discrete because I can't buy parts of DVDs. Okay, and then the graph, again, it's money, so it's all going to be positive. We have 0, 1, 2, 3, 4, and 5, and we would start up here at 50, and we work our way down, 41, etc. I'm not gonna, it doesn't ask us to put in the things, but we could see a steady decrease. Oops, that's not a very good graph. Hold on. Okay, we don't quite reach 0 at 5. It's still at 5, so we're a little bit above, and we can kind of pace ourselves, climbing the same amount. All right, and then find the range of the function. Well, we kind of did that when we were talking over here, the range of these values. So it's going to be the m, such that m equals 5, 14, 23, 32, 41, and 50. Squeeze that in there. All right. A cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. Find the domain of the function. Is the domain discrete or continuous, and explain. All right, so a cereal bar number of bars eaten. Well, this one, I'm thinking I would argue that it's going to be a continuous because you can eat parts of bars. You could just like nibble a tiny and infinitesimal amount. So I'm going to call it continuous and say that you could go eat 0 all the way up to, well, there's really no limit here, right? The cereal bar, you just keep eating bars. It doesn't say on a specific day or over time. So you could just keep eating. So we would describe that. The domain would be the set of B, bars eaten, such that, well, we could eat 0, and we could go forever towards infinity. All right. Graph the function using its domain. All right, so if we start at 0 bars, we'd have 0 calories, and then as we eat, the more we eat, it's just going to steadily increase. Okay. So we just keep going because the domain starts here at 0 and continues forever. All right. Find the range of the function. Well, it's pretty much the same values as the domain because we'd start here at 0 on the y-axis and it's going to continue forever. So the range would be the set of C, because calories, and C would be from 0 to infinity. All right, given this graph, or table, sorry, is the domain discrete or continuous, and explain. So the input is the number of stories, the output is the height of the building. So discrete or continuous, we only care about the input. Discrete was each one's individual, nothing in between, or in continuous is over an interval. So if we're talking about the number of stories in a building, I believe those would be considered discrete because you would just count each floor, right? So if I have this building, I have 1, 2, looks like three stories. Okay. Even if I were in the process of building the building, right, and I'd already put in 1, 2, and 3, if I've started the next one, that's a 4th floor. It's not part of a floor. It's a story of the building. So we're going to call this one discrete. And my explanation is once you start building the story, you have a story. It's not part of it's not considered to be part of a story. All right. If we have a 20-gallon bathtub and it's draining at a rate of 2.5 gallons per minute, the number G of gallons remaining is a function of the number M. Okay, right there. Function of the number M. They just told us M is our independent, our input, and G is our dependent. Okay, so to find the domain, we're talking about the M values. So our M values are the minutes that have passed. All right. Well, I have a little bit of a problem with this because they don't tell me how many minutes have passed. So I'm going to have to kind of think here. Before I pull the plug, at 0 minutes, I have 20 gallons. Okay. And then that water starts draining. Time's just ticking away, right? So it's just ticking away. And eventually, the bathtub is going to be empty. Right? So if it's 2.5 gallons per minute, they're saying 2.5 gallons every minute. And I want to know when 20 gallons would be drained. Okay, so it's a proportional relationship. I could multiply, do the cross multiplication, and we'll just call that 2.5x, or M. is equal to 20. So if 2.5 m equals 20, then when 20 gallons have drained, 18 minutes. Is it 18? That's not right. It's just 8. Silly me. Okay, 8 minutes would have passed. So to answer the first question, the domain is going to be our m values, and m is going to go from 0 to 8. And this is a continuous, because the water is continually flowing out. The function to graph it, right, we would start with 20 at 0, and it would steadily decrease until we got over here to 8. Okay. And that would be a line, because it's continuous. And then find the range. The range is going to be the set of G, and we're going to go from 0 to 20. And that is the end of our notes.